Hey guys, hi, welcome back. So in the previous video, we have seen the electric field intensity due to dipole on the axial line, right? So in this video, we will see the electric field intensity due to dipole on the equatorial line. So we already know what is the equatorial line, the line which is passing through the center of the dipole, right? So we will just calculate in the similar way as we have done for the axial line and the dipole at the center. Both are same, okay? The same thing we will be doing here. So for this, what we will do, we will first make a dipole, okay? So I'm considering this point to be A, and I'm placing the negative charge to be here and positive charge to be here. And this is the point B. So this is a dipole, and the center of the dipole, I'm considering it to be O, right? We know the direction of the dipole is always negative to positive. And the separation between the dipole is 2L. And this distance from the center will be obviously L. And this is also L. Okay, the distance is L. Now, what we are asked, electric field intensity due to dipole on the equatorial line. So I'm drawing a line passing through the center, which is the equatorial line. And I'm considering a point P here. This is the point P on the equatorial line. So we will place a test charge here and we will calculate the electric field intensity. And this distance, I'm considering it to be R, right? So in order to calculate the electric field intensity, we know the formula is what? 1 by 4 pi epsilon naught Q by R square. So this R is the distance between the charge and the test charge, right? So for this, we will need to join this AP, right? We will need to join just a second. Okay, so we have joined the point AP. Similarly, we will join the point BP also, because we will find the electric field intensity due to the charge plus Q also. So you need to make straight lines, clear? So this is what I have written here. Let AB is a dipole of length 2L centered at O. P is any point on the equatorial line, okay? And that is the point where the electric field intensity has to be calculated. So first we will write the electric field intensity due to minus Q charge, but we know the formula. We will write E1 is equals to 1 by 4 pi epsilon naught, which is K. I'm writing it to be K, okay? The charge, I'm writing it to be Q by 4 pi epsilon naught. I'm not writing, just the R square, right? So if you see here, this is the perpendicular bisector. So this is your 90 degree. So when we will apply Pythagoras theorem in triangle AOP, what we will get? The hypotenuse square, that is AP square, is equals to what? OA square plus OP square. That means AP square is equals to OA is L square, right? So it is L square plus R square. And we can write by rearranging AP is equals to root over R square plus L square. Okay. And we know AP and here BP will be same because the sides are equal. So directly what we will write here, it is root over R square plus L square whole square. So you can directly write it as KQ upon R square plus L square. Okay. And this is along which direction? This is negative charge, this is positive charge. So we know this negative charge will attract the test charge. So it is along PA. So the direction of E1 is in this direction. Okay, so you can write along PA. Okay, this is along PA. Similarly, electric field intensity we will write for plus Q charge. So E2 is equals to same the charge KQ by the distance. The distance is same again. BP, which is R square plus L square whole square. So you can write it to be equals to E2 is equals to KQ by R square plus L square. Now let us see the direction. So this is what? Both are positive charges, right? This is a positive charge. This is also positive charge. So obviously this charge will be repelled. Okay. So it will be along Which direction? Obviously it is away. Okay, I can write it along this particular direction. This is your E2, right? So this is along which direction? Along BP. Clear? So we have written electric field intensity E1 and E2. Now when we see this, you are having E2 in this direction, E1 in this direction. So you're having vector. We can use the vector properties, right? So when we will use the vector properties, what we will see that the dipole and this line AP, it makes an angle theta, right? So when we will draw a line parallel to it, means the line is drawn somewhere here. So what it will be? This angle will be also theta. This will be also theta. Okay, when we will draw a line parallel, this is alternate angle and transversal corresponding angle. These things, you know, so according to that. Okay, so this angle is also your theta. Okay, and this is also theta, this side. If we are taking the dipole direction in this direction, this is also theta. So now if you see, when we will resolve this, okay, when we will resolve this, you can see this angle is theta. So this side, what you will have? E1 cos theta, and the projection will be taken on the other side. This is E1 sin theta. Similarly, this angle is also theta. So if you see here, E2 cos theta is also in the same direction, and the projection will be on the opposite side, that is E2 sin theta. We will see this E2 sin theta and E1 sin theta, sorry, they will cancel each other, right? So you will have the net electric field E, it is equals to what? E1 plus E2 cos theta. What do you have? Cos theta. So now first we will calculate what is the value of cos theta using the triangle AOP. Okay. So what you will write here in triangle AOP, cos theta. Cos theta formula we know. As we have seen, cos theta is what? Base upon hypotenuse, right? So base upon hypotenuse. So base is here your OA and your hypotenuse is what? AP. That means it is L upon root over R square plus L square. So this we will substitute here. The same thing will be there. So E is equals to, if you see both the values, KQ by R square plus L square, KQ by R square plus L square. So when you will add, you can directly write it to be 2KQ by R square plus L square into with cos theta, that is L root over R square plus L square. Okay. So if you see here, in this case, you can write E is equals to 2KQL by R square plus L square whole to the power 3 by 2. Why it is 3 by 2? Because you have seen here the power is 1 by 2 and 1. When we will add, we will get it to be 3 by 2. Okay. In the next step, what we will write? E is equals to, we know Q into with 2L is the dipole. So here this Q and this 2L will give you what? P, and divided by R square plus L square whole to the power 3 by 2. So this is your electric field intensity at the point P. Okay, so I'm continuing in this side. Special case when you are having small dipole. Okay, in case of small dipole means when your L is very, very less than R. Okay, then you will put L is equals to what? 0. So you will get, in that case, the electric field E is equals to Kp upon L is 0. So you will have what? R square whole to the power 3 by 2. 2 and 2 gets cancelled, and you can write E is equals to Kp upon R cube. Okay, and this P, you can put the vector symbol. So this is the net electric field due to dipole on equatorial line, and this is for short dipole, and this is the general formula. Clear? So this is how you can calculate. The terms are very easy. You need to know to write the electric field intensity due to charge Q2, then charge Q1. Okay, so here Q1 is your minus Q, Q2 is plus Q, because we know what is dipole. Dipole is one positive charge and one negative charge constitutes a dipole. Clear? And then you will check for the vectors and then resolve it and just do it. Okay, so that's all in this video. Thank you so much. Have a good day.